All right, so we just talked about a bunch of the closed weight models. Well, let's talk about the open ones. So tell me about the landscape of open LLM models. Which are interesting ones? Which stand out to you, and why? We already mentioned DeepSeek.
Do you want to see how many we can name off the top of our head?
Yeah, without looking at notes.
DeepSeek, Kimi, Minimax, Z.ai, Antling. We're just going Chinese.
Let's
Yeah.
throw in Mistral AI, Gemma, GPT OSS, the open source model by ChatGPT. Actually, NVIDIA had a very cool one, Nemotron 3. There's a lot of stuff, especially at the end of the year. Quen, maybe the one.
Oh yeah, Quen was the obvious name I was missing. I was trying to get through you can get at least 10 Chinese and at least 10 Western. I think that, OpenAI released their first open model since GPT-2. That was when I was writing about OpenAI's open model release. They're all like, "Don't forget about GPT-2," which I thought was really funny because it's just such a different time. But GPT OSS is actually a very strong model and does some things that the other models don't do very well. And I think that selfishly, I'll promote a bunch of like Western companies. So both in the US and Europe have these like fully open models. So I work at Allen Institute for AI, where we've been building Olmo, which releases data and code and all of this. And now we have actual competition for people that are trying to release everything so that other people can train these models. So there's the Institute for Foundation Models, or / LLM 360, which is like had their K2 models of various types. Aperdis is a Swiss research consortium. Hugging Face has small LM, which is very popular. And NVIDIA's Nemotron has started releasing data as well. And then Stanford's Marin Community Project, which is kind of making it so there's a pipeline for people to open a GitHub issue and implement a new idea and then have it run in a stable language modeling stack. So this space, that list was way smaller in 2024. Mm-hmm. So I think it was like just AI2. So that's a great thing for more people to get involved and to understand language models, which doesn't really have a Chinese company that has an analog. While I'm talking, I'll say that the Chinese open language models tend to be much bigger, and that gives them this higher peak performance as MOEs, where a lot of these things that we like a lot, whether it was Gemma and Nemotron, have tended to be smaller models from the US, which is starting to change from US and Europe. Mistral Large 3 came out, which was a giant MOE model, very similar to DeepSeek architecture in December. And then a startup, RCAI, and both Nemotron and NVIDIA have teased MOE models of this way bigger than 100 billion parameters, like this 400 billion parameter range coming in this like Q1 2026 timeline. So I think this kind of balance is set to change this year in terms of what people are using the Chinese versus US open models for, which I'm personally going to be very excited to watch.
First of all, huge props for being able to name so many of these. Did you actually name Llama?
No.
I feel like
R.I.P.
This was not on purpose.
R.I.P. Llama.
Mm-hmm.
All right. Can you mention what are some interesting models that stand out? So you mentioned Quen 3 is obviously a standout.
So I would say the year's almost bookended by both DeepSeek version 3 and R1, and then on the other hand, in December, DeepSeek version 3.2, because what I like about those is they always have an interesting architecture tweak that others don't have. But otherwise, if you want to go with, like the familiar but really good performance, Quen 3, and like Nathan said, also GPT OSS. And I think GPT OSS, what's interesting about it is kind of like the first public or like open weight model that was really trained with tool use in mind, which I do think is kind of a little bit of a paradigm shift where the ecosystem was not quite ready for it. So with tool use, I mean that the LLM is able to do a web search, to call a Python interpreter. And I do think it's a standout because I think it's a huge unlock, because one of the most common complaints about LLMs are, for example, hallucinations, right? And so in my opinion, one of the best ways to solve hallucinations is to not try to always remember information or make things up. For math, why not use a calculator app or Python? If I ask the LLM who won the soccer World Cup in 1998, instead of just trying to memorize, it could go do a search. I think mostly it's usually still a Google search. So ChatGPT, GPT OSS, they would do a tool call to Google, maybe find the FIFA website, find, okay, it was France. It would get you that information reliably instead of just trying to memorize it. So I think it's a huge unlock, which I think right now is not fully utilized yet by the open source, open weight ecosystem. A lot of people don't use tool call modes, because I think it's a trust thing. You don't want to run this on your computer where it has access to tools, could wipe your hard drive or whatever. So you want to maybe containerize that. But I do think that is like a really important step for the upcoming years to have this ability. Yeah.
So a few quick things. First of all, thank you for defining what you mean by tool use. I think that's a great thing to do in general for the concepts we're talking about. Even things as sort of well established as MOEs, you have to say that means mixture of experts, and you kind of have to build up an intuition for people what that means, how it's actually utilized, what are the different flavors. So what does it mean that there's just such explosion of open models? What's your intuition?
If you're releasing an open model, you want people to use it as the first and foremost thing. And then after that comes things like transparency and trust. I think when you look at China, the biggest reason is that they want people around the world to use these models. And I think a lot of people will not. If you look outside of the US, a lot of people will not pay for software, but they might have computing resources where you can put a model on it and run it. I think there can also be data that you don't want to send to the cloud. So the number one thing is getting people to use models, use AI, or use your AI that might not be able to do it without having access to the model.
I guess we should state explicitly. So we've been talking about these Chinese models and open weight models. Oftentimes the way they're run is locally. So it's not like you're sending your data to China or to whoever developed, to Silicon Valley, whoever developed the model.
A lot of American startups make money by hosting these models from China and selling tokens. It's called like selling tokens, which means somebody will call the model to do some piece of work. I think the other reason is for US companies, like OpenAI is so GPU deprived. Like they're at the limits of the GPUs. Whenever they make a release, they're always talking about like our GPUs are hurting. And I think there's like in one of these like GPT OSS release sessions, Sam Altman said like, "Oh, we're releasing this because we can use your GPUs. We don't have to use our GPUs, and OpenAI can still get distribution out of this," which is another very real thing because it doesn't cost them anything.
And for the user, I think also, there are users who just use the model locally, how they would use ChatGPT, but also for companies, I think it's a huge unlock to have these models because you can customize them, you can train them, you can add post-training, add more data, like specialize them into, let's say, law, medical models, or whatever you have. And the appeal, you mentioned Llama, the appeal of the open weight models from China is that the open weight models are also, the licenses are even friendlier. I think they are just unrestricted open source licenses where if you use something like Llama or Gemma, there are some strings attached. I think it's like an upper limit in terms of how many users you have. And then if you exceed, I don't know, so many million users, you have to report your finance situation to, let's say, Meta or something like that. And I think, well, it is a free model, but there are strings attached and people do like things where strings are not attached. So I think that's also one of the reasons, besides performance, why the open weight models from China are so popular, because you can just use them. There's no catch in that sense. Yeah.
The ecosystem has gotten better on that front, but mostly downstream of these new providers providing such open licenses. That was funny when you pulled up Perplexity. It said Kimi K2 Thinking hosted in the US, which is just like I've never seen this, but it's an exact example of what we're talking about where people are sensitive to this. Like Kimi K2 Thinking and Kimi K2 is a model that is very popular. People say that has very good like creative writing and also in doing some software things. So it's just these little quirks that people pick up on with different models that they like.
What are some interesting ideas that some of these models have explored that you can speak to, like that particular interesting to you?
Maybe we can go chronologically. There was, of course, DeepSeek R1 that came out in January, if we just focus on 2025. However, this was based on DeepSeek version 3, which came out the year before in December 2024. There are multiple things on the architecture side. What is fascinating is you can still, that's what I do in my from scratch coding projects. You can still start with GPT-2 and you can add things to that model to make it into this other model. So it's all still kind of like the same lineage, it is a very close relationship between those. But top of my head, DeepSeek, what was unique there is the mixture of they were not inventing mixture of experts. We can maybe talk a bit more what mixture of experts means. But just to list these things first before we dive into detail, mixture of experts, but then they also had multi-head latent attention, which is a tweak to the attention mechanism, where this was, I would say, 2025, the main distinguishing factor between these open weight models, different tweaks to make inference or KV cache size. We can also define KV cache in a few moments, but to kind of make it more economical to have long context, to shrink the KV cache size. So what are tweaks that we can do? And most of them focused on the attention mechanism. There is multi-head latent attention in DeepSeek. There is group query attention, which is still very popular. It's not invented by any of those models. It goes back a few years, but that would be the other option. Sliding window attention, I think almost 3 uses it, if I remember correctly. So there are these different tweaks that make the models different. Otherwise, I put them all together in an article once where I just compared them. They are very surprisingly similar. It's just different numbers in terms of how many repetitions of the transformer block you have in the center, and like just little knobs that people tune. But what's so nice about it is it works no matter what. You can tweak things. You can move the normalization layers around. You get some performance gains. And OMO is always very good in ablation studies, showing what actually what it does to the model if you move something around. Ablation studies, does it make it better or worse? But there are so many, let's say, ways you can implement a transformer and make it still work. Big ideas that are still prevalent is mixture of experts, multi-head latent attention, sliding window attention, group query attention. And then at the end of the year, we saw a focus on making the attention mechanism scale linearly with inference token prediction. So there were Qwen3 Next, for example, which added a gated delta net. It's like kind of like inspired by state space models where you have a fixed state that you keep updating, but it makes essentially this attention cheaper, or it replaces attention with a cheaper operation.
And it maybe is it useful to step back and talk about transform architecture in general?
Yeah, so maybe we should start with the GPT-2 architecture. The transformer that was derived from the attention is all you need paper. Mm-hmm. So the attention is all you need paper had a transformer architecture that had 2 parts, an encoder and a decoder. And GPT went just focusing in on the decoder part. It is essentially still a neural network, and it has this attention mechanism inside. And you predict one token at a time. You pass it through an embedding layer. There's the transformer block. The transformer block has attention modules and a fully connected layer. And there are some normalization layers in between. But it's essentially neural network layers with this attention mechanism. So coming from GPT-2, when we move on to GPT OSS, there is, for example, the mixture of experts layer. It's not invented by GPT OSS. It's a few years old. But it is essentially a tweak to make the model larger without consuming more compute in each forward pass. So there is this fully connected layer, and if listeners are familiar with multi-layer perceptrons, you can think of a mini multi-layer perceptron, a fully connected neural network layer inside the transformer. And it's very expensive because it's fully connected. If you have 1,000 inputs, 1,000 outputs, that's like 1 million connections. And it's a very expensive part in this transformer. And the idea is to kind of expand that into multiple feed-forward networks. So instead of having one, let's say you have 256, but it would make it way more expensive because now you have 256, but you don't use all of them at the same time. So you now have a router that says, okay, based on this input token, it would be useful to use this fully connected network. And in that context, it's called an expert. So a mixture of experts means you have multiple experts. And depending on what your input is, let's say it's more math heavy, it would use different experts compared to, let's say, translating input text from English to Spanish. It would maybe consult different experts. It's not quite clear, as clear cut to say, okay, this is only an expert for math and for Spanish is a bit more fuzzy. But the idea is essentially that you pack more knowledge into the network, but not all the knowledge is used all the time. Mm-hmm. That would be very wasteful. So you're kind of like, during the token generation, you're more selective. There's a router that selects which tokens should go to which expert. It's more complexity. It's harder to train. There's a lot of, that can go wrong, like collapse and everything. So I think that's why Olmo 3 still uses dense. You have, I think, Olmo models with mixture of experts, but dense models, where dense means, so also it's jargon. There's a distinction between dense and sparse. So mixture of experts is considered sparse because we have a lot of experts, but only few of them are active. So that's called sparse. And then dense would be the opposite, where you only have like one fully connected module and it's always, utilized.
So maybe this is a good place to also talk about KV cache, but actually before that, even zooming out, like fundamentally, how many new ideas have been implemented from GPT-2 to today, like how different really are these architectures?
Picture like the mixture of experts. The attention mechanism in GPT-OSS, that would be the group query attention mechanism. So it's a slight tweak from multi-head attention to group query attention. So there we have two. I think they replaced layer norm by RMS norm, but it's just like a different normalization layer. Not a big change. It's just like a tweak. The nonlinear activation function, people familiar with deep neural networks, I mean, it's the same as changing sigmoid with ReLU. It's not changing the network fundamentally. It's just like a tweak, like a little tweak. And that's about it, I would say. It's not really fundamentally that different. It's still the same architecture. So you can convert you can go from one into the other by just adding these changes, basically.
It fundamentally is still the same architecture.
Yeah. So, for example, you mentioned my book earlier. That's a GPT-2 model in the book because it's simple and it's very small. So 120 million parameters approximately. But in the bonus materials, I do have almost 3 from scratch, Gemma 3 from scratch, and other types of from scratch models. And I always started with my GPT-2 model and just, tweaked added different components, and you get from one to the other. It's kind of like a lineage in a sense. Yeah.
Can you build up an intuition for people? Because sort of when you zoom out, you look at it, there's so much rapid advancement in the AI world. And at the same time, fundamentally, the architectures have not changed. So where is all the turbulence, the turmoil of the advancement happening? Where's the gains to be had?
So there are the different stages where you develop the network or train the network. You have the pre-training. Now, back then it was just pre-training with GPT-2. Now you have pre-training, mid-training, and post-training. So I think right now we are in the post-training focus stage. I mean, pre-training still gives you advantages if you scale it up to better, higher quality data. But then we have capability unlocks that were not there with GPT-2. For example, ChatGPT, it is basically a GPT-3 model, and GPT-3 is the same as GPT-2 in terms of architecture. What was new was adding the supervised fine-tuning and the reinforcement learning with human feedback. So it's more on the algorithmic side rather than the architecture.
I would say that the systems also change a lot. I think if you listen to NVIDIA's announcements, they talk about these things like you now do FP8, you can now do FP4, and what is happening is these labs are figuring out how to utilize more compute to put it into one model, which lets them train faster, and that lets them put more data in, and then you can find better configurations faster by doing this. So you can look at essentially the tokens per second per GPU is a metric that you look at when you're doing large scale training, and you can go from like 10K to 13K by turning on FP8 training, which means you're using less memory per parameter in the model. And by saving less information, you do less communication, you can train faster. So all of these system things underpin way faster experimentation on data and algorithms. That is kind of it's this kind of loop that keeps going, where it's kind of hard to describe when you look at the architecture and they're exactly the same, but the code base used to train these models is going to be vastly different. And you could probably, the GPUs are different, but you probably train GPT-OSS 20B way faster in wall clock time than GPT-2 was trained at the time.
Yeah, like you said, they had, for example, in the mixture of experts, this FP4 optimization, for example, where you get more throughput. But I do think this is, for the speed, this is true, but it doesn't give the model new capabilities in a sense. It's just how much can we make the computation coarser without suffering in terms of model performance degradation. But I do think, there are alternatives popping up to the transformer. There's text diffusion models, completely different paradigm. And there's also, although text diffusion models might use transformer architectures, but it's not an auto-regressive transformer. And also Mamba models, it's a state space model, but they do have trade-offs. And what's right is there's nothing that has replaced the auto-regressive transformer as state-of-the-art model. So for state-of-the-art, you would still go with that thing. But there are now alternatives for the cheaper and alternatives that are kind of making compromises, but it's not just one architecture anymore. There are little ones coming up, but if we talk about the state of the art, it's pretty much still the transformer architecture, autoregressive, derived from GPT-2 essentially.